University of Texas at Dallas and VL Offshore are developing MarsVAWT and FloatVAWT TLP-type floating wind systems to support vertical wind turbine. The project is funded by U.S. DOE ARPA E-Atlantis program. The MarsVAWT platform is configured with multiple modules allowing serial fabrication, while the FloatVAWT platform is a conventional compact hull with light hull mass. Mass center of hull with VAWT system is low due to the generator location underneath the tower base. Overturning moment of the hull with VAWT is smaller when comparing to the horizontal axis wind turbine. These key features result in lighter hull mass and low cost. As turbine size grows, fabrication of a floating wind foundation will face infrastructure issues in hull fabrication capacity, shipyard land space, and port depth. The immediate challenges are on the U.S. floating wind projects, especially in West Coast due to limited infrastructure for a large foundation for a large wind turbine. The challenge can be overcome with an innovative modular platform, MarsVAWT. The modular hull consists of outer columns, outer pontoon with node, center pontoon, and turbine support frame with interface node for local fabrication. The modules are assembled with mechanical connection. The modular foundation allows for optimized series production that increases the fabrication efficiency and local facility utilization that expands the domestic supply while reducing the wind farm total cost and risk. The modular fabrication allows for floating assembly using mechanical connections, which reduces the assembly and load-out time significantly and facilitates its assembly at more locations. Therefore, project requiring large floating wind turbine will be more feasible and viable for U.S. floating wind project. Each module is fabricated at local yards and transported for assembly. Fabricated modules are loaded out to a barge or similar vessel for transport. The loaded barges are transported to the assembly site. The modules are assembled on water using mechanical connection. First, ponton module connection. Outer column module connection 1 by 1 using crane. The turbine support frame connection to the completed pontoon. The barge is ballasted down and removed. The completed foundation now floats on water. Lastly, tower integration to the foundation, followed by the turbine rotor integration. The platform is ballasted to a wet tow draft and towed from quayside to installation site. The MarsVAWT platform is connected with high-tension vertical mooring system and starts the operation for power production. Wet tow of FloatVAWT is simulated to confirm wet tow feasibility of the platform with the VAWT system from quayside to installation site and identify potential risks during the wet tow. MarsVAWT is simulated for various load cases to validate the designs, including platform performances, tendon responses, and structural designs. This simulation clip presents responses of a 15 megawatts MarsVAWT platform moored at 800-meter offshore California in a 50-year extreme and turbine-parked condition. Structural finite element analysis results also confirm the structural designs complying with industry design standards. The three-bladed VAWT system is scaled to generate a overturning moment, which is equivalent to one of IEA 15 megawatts horizontal axis wind turbine. The VAWT is then mounted on a semi-submersible model for a series of tests such as system identification, system damping, parked loads, and turbine performances under regular and irregular waves.